So now we're going to visit relay contacts. And remember, relays are electrically controlled switches, and we use those for a variety of reasons, for mixed mode voltages, for higher currents that we can control with lower currents, for the very fact that we can know the status of the relay, whether it's energized or de-energized, by using either the normally open or normally closed relay contacts. So there's bunches and bunches of reasons that we use relays. And we energize the coil to change the state of the contacts. And remember, normally open contacts are closed to allow for current flow when the coil is energized, and normally closed contacts are closed when the relay coil is not energized. So we can make different things happen based on whether we're energizing the coil of a relay, and that can be a look into other outputs that energize these relays to let us know what we need to do from a control sequence standpoint. So I want to first wire up and look at the normally open relay contact. It's the one that gets used most often. So I'm going to do what we normally do. We would start with our power side, go through a switch, and come out of our switch, and we'd energize a relay coil. And so we're getting power to the coil, and we got to take the other side to L2, which in this case is our ground for DC. I wanted that to be black, so let me kill that and change that to be black. So there we go. Now, all I'm going to do when I press this push button is energize this relay. And in the real world, if it's a mechanical relay, we would hear that relay click. But we're not doing anything with our switches, which is the whole purpose of using a relay, is to be able to manipulate other parts of our control sequence with this electrically controlled. So by changing the state of this coil, we can change the state of other devices through these switches here, which are just electrically controlled. And again, this normally open contact is the one that we most often use because it becomes, it conducts when, or closes when the relay coil is energized. So the first thing I've got to do is I've got to bring power to it so that it can control something. And we're going to let it control our red lamp here. So I'm going to come out of my normally open, go to my red lamp, and I'm going to put a black lead off of my red lamp to my ground. And we know that this normally open contact is not going to close until this relay coil is energized. And this relay coil is being energized is not going to happen until we press that push button. So let's turn on our power, and notice our lamp is not on. We're going to manipulate this switch, and notice that as soon as we do, we energize our relay coil. The energizing of that relay coil changes the state of this contact, causing our lamp to be on. Now, I want you to look at the flip side of this, which is the normally closed contact. And we're going to come out of it. Now, we're already bringing power in. This power is switched either through the normally open or the normally closed. So whatever I put on this pin is either going to go through this path or this path, depending on the state of the relay coil. So we're going to come out of there, and we're going to go to our green lamp. Now, because one of these is going to, we got to add our ground. Because one of these is going to our normally open and one is going to our normally closed, that means that I'm taking one to the red lamp, one to the green. They should never be on at the same time. If there is, there's something amiss, because either this relay coil is energized and we're providing a path through the normally open, or it's de-energized and we're providing a path through the normally closed. So as soon as I power this on, we should see the green lamp come on, and we do. And that's because we're going through the normally closed, which is closed and providing a path for current as long as the coil is not energized. Now, when I press this button, the coil becomes energized and the pathway goes through this contact rather than through this contact. And I can release that button, I can press it, and I can release it, and I can press it, and I can release it. So you can already see this would have some nice implications from an electrical standpoint, and we can definitely see the difference between a normally open relay coil contact, not a relay coil contact, but a normally open relay contact and a normally closed relay contact, which do swap states based on the state of the relay coil. So that's the beauty of relays and why we use them. And that's why the contacts are so important. Again, the primary one is the normally open. We see that more often. In fact, some relays only have this normally open, but some have both normally open and normally closed. Just kind of depends on what we're trying to do and make happen. So there is your first introduction to that.